So the steering is done by this motor, and it just goes left and to the right, which makes me believe it's a servo motor. So this is a servo motor. I wrote a quick little program that makes it go back and forth. So this servo with 0 to 180 degrees of rotation. So this servo and most others like it have 3 wires: ground, power, and the signal. So right off the bat, I can see something that's a little different. We have 4 wires. Not what I was expecting. Okay. So, I was correct. Now, I'm guessing those 2 are going to be plus or minus. And I don't know if this is bipolar, so let's find out. So this is just a test. I have it set to 5 volts. Let's just see what happens. So right now I have red to red, black and black. Okay. So I won't go any further. And if I reverse it, okay. So there's bipolar. So what are the other 2 for? Well, let's get the voltmeter out. Okay, so I have the voltmeter connected to the 2 mystery pins. And if I go to the far left, almost 0 resistance. Middle is about 2,000. And then 5,000. So, interesting. So, it appears I'm going to have to run the servo by myself. Maybe I can use Arduino to determine what the resistance is between these 2, and then know which way where it currently is, so then I can tell it to go to the left or to the right, and it will know which way to go. In order to recreate what the multimeter does in an Arduino, we have to use a voltage divider. A voltage divider is a simple circuit that turns a large voltage into a smaller one. But what we're going to be using, the voltage divider, is to find out what the resistance is of a potentiometer, or in our case, the servo motor. Now, let's do some math. This is the equation used to calculate the voltage after the voltage divider. R1 and R2 are resistors. Vn is the initial voltage, and Vout is the output voltage. So let's say Vn is 5 volts. R1 and R2 are both 10k ohm resistors. So 10 divided by 10 plus 10, or 20, is the same as 1/2. So 5 times half is 2.5. Vout will be 2.5 volts. What if you don't know what one of the resistors is? In our case, we don't know what R2 is, because that's going to be coming from the servo. Let's rearrange the equation to something that will better fit our needs. With this equation, we can find out what R2 is. Vn would be 5 volts from the Arduino. R1 would be a 10k ohm resistor. Vout will go to one of the analog pins of the Arduino. And R2 will be plugged into the servo motor. This is an Arduino sketch I made to find out what the resistance is for the servo motor at different locations, if it's in the middle or if it's turning left or right. I've set R1 to be 10 for the 10k resistor, and Vn is set to 5 volts from the Arduino. The Arduino's analog input read voltages. It returns a number between 0 and 1023, which represents 0 volts, or ground, up to 5 volts. We have to convert that number back into volts, though, for the math to work. Here is the equation in mathematical form. It takes in the voltage and all these other values for the resistor, and gives us the resistance from the servo. So let's check the serial monitor and find out what values we're getting. So if we go to the serial monitor, right now the servo is in the middle. So these values are in the thousands. So this is 2.51 k ohms. So if I move the servo to the far right, it's now giving us about 0.39. We'll go all the way to the far left. It's giving us almost 5 k ohms. So in the middle is about 2.7. So with these values and this simple math, I can know exactly where the servo is.